Let me present the results of our research described in the article titled Neural Network Technologies of Investment Risk Estimation, taking into account the legislative aspect. The authors of the article are Anzhelika Azarova, Larisa Azarova, Lilia Nikiforova, Veronika Azarova, Olena Teplova, Natalia Krivinska. Formal problem statement. To estimate the investment risk, it's necessary to take into account a large set of input parameters X, output parameters R, and their mapping function F fast. The authors propose to decompose a complex investment problem into a sequence of simpler problems so that the solution of any lower level problem determines certain parameters in the higher level problem. The solution of the complex problem of investment risk estimation becomes possible when the solution of all lower level subtasks are obtained. The peculiarity of the investment-making decision process is a consistent implementation of the function F. The task of investment project risk estimation is to choose an adequate solution R from a set of decisions, possible levels of risk of the IP. The authors propose to make a choice based on the classification of investment objects according to investment strategies on the basis of a set of X evaluation parameters Xi. Taking into account all the above factors, we offer the following general mathematical model for investment risk estimation, which can you see on this slide. So that X we start is a set of primary input parameters. X, this is a set of evaluation parameters. Y, this is a general set of investment decisions. R, generalized set of investment decisions. Function F fast, function of transformation of primary input parameters into evaluation parameters of model. Function F second is generation function. Function F third is a function of classification of investment objects according to investment strategies. So you can see the mapping of the set of primary input parameters X we start to a results set of investment decisions R. To obtain the final result, risk level R, based on the set of primary input parameters X we start, it's necessary to implement the above function in the following sequence. X with start maps to the set of result decisions R. So the author propose such a structural model of the process of estimation the level of investment risk, which is shown on the figure on the slide 4. The proposed structural model allows classifying IP according to 3 investment strategies, which correspond to the following values of risk RG. R fast, minimum level of risk, investment is appropriate. R second, medium level of risk, investment is possible in case of application of risk reduction methods. R third, high level of risk, investment is impractical. Using the method of pairwise comparison study on the basis of questionnaires of employers of credit analysis departments of banking institutions in Vinnytsia was substantiated a limit values of evaluation indicators according to which you can divide the range of values of each of 10 evaluation parameters into three ranges: L, low, M, medium, and RH, high characteristic level of indicator. This process you can see at the table number 1. Formalization of the mathematical model of the investment risk estimation process. With the development of artificial intelligence systems and computerized information process tools, it becomes possible to productively solve the problem of investment risk estimation. The most productive means of neural technology of investment risk estimation is the Hamming network. It was developed by Richard Lippmann in the middle of 1980s. The choice of Hamming network among other similar networks is due to its following advantages. It implements the optimal minimum error classifier if the input bit errors are random and independent. A smaller number of neurons is required for the Hamming network to function because the middle layer requires only one neuron per class instead of a neuron for each input node. Finally, the Hamming network is free if incorrect classification that may occur, in particular in the Hopfield network. In general, the Hamming network is both faster and more accurate than the Hopfield network and many other classification networks. Therefore, to formalize the process of mapping the set of primary parameters X we start to the set of result decisions R of initial solutions, risk levels, the answer of the article proposed to use the Hamming neural network. We implement the structural model of investment risk estimation process built on the basis of Hamming neural network as shown in a figure second. With the help of expert data and the spectral method of processing expert information, 5 references images of EP for the neural network were substantiated. They correspond to 3 levels of investment risk RG. Set 1 and set 2 describe an investment strategy with R fast risk. Set 3 describe a strategy with R second risk. And set 4 and 5 describe a strategy with R third risk. It's known that the Hamming network works with the numerical values 1 and -1. So, after obtaining the levels of indicators high, medium, lower, the process to apply the Hamming algorithm proposed to encode the values of indicator in ordinary binary code. The code format should consist of 2 digits, which allows you to encode 4 2 in degree of 2 possible values of the evaluation parameter. Note that the investment project is characterized by only 3 strategies RG at the output of the model. So there is a need to encode only 3 levels of indicators. low level of indicator -1, -1, medium level of indicator -1, 1, high characteristic level of indicator 1, 1. After the construction of the network, a vector of coded 20 values of 10 evaluation parameters x, which characterize the investment attractiveness of the particular enterprise, is fed to its entrance. The neural network identifies the standard that is closest to the vector fed to its input. The number of these standards allows you to classify the resulting decision to assign the appropriate level of risk Rg. The method of estimating the level of investment risk by means of Hamming neural network. First, the input is given the values of the primary indicators x with start, which are used to calculate the evaluation parameters x based on the relevant dependencies. Second, the values of the evaluation parameters x fast to x tens using the appropriate ranges of values are described by a specific characteristic level L low, M medium, H higher. Third, each evaluation parameter described by a certain characteristic level is assigned a corresponding binary code. Fourth, the input vector of Hamming network have to be formed. Coded combination of 20 digits, 1 and -1. Fifth, the Hamming neural network identifies the closest to the input vector standard, the number of which is used as the network output. In this case, each of the standards corresponds to a certain level of investment risk R. Consider the process on investment risk estimation in the mathematical model proposed by the authors, formalized using the apparatus of Hamming network on the example of enterprise number 1. For the computer implementation of the process Hamming network, the authors of the article have developed a corresponding software product investor based on which the value of parameters x was calculated, as illustrated in figure, to estimate the level of investment risk of enterprise number 1. Based on the developed software product investor, the values of the parameters x, the linguistic terms corresponding to them, as described in table above, as well as the corresponding Hamming codes given in table 2, were evaluated. We reduce all this data to the table which you can see in this slide. The level of investment risk of enterprise number 1, which is described by a coded set of values 20-digit code, using the software product investor, is evaluated by a standard number 4. That is, the level of investment risk of this business entity is minimal. Similarly, for another foreign analyzed enterprises using the software product investor were formed input vectors of Hamming network coded combination of 20 digits 1 and -1 as indicated in the table which can you see in this slide. It was identified as the closest to the input vector standard among those described in table 2, the number of which is used as the network output. This number uniquely identifies the investment decision for a particular entity, which is shown in slide, which can you see? So, in both of these and next slides, you can see all conclusions by our research. So, significant advantages of proposed method over existing alternative methods are: first, accuracy of estimation; second, taking into account a wide range of different evaluation parameters; third, speed; fourth, the ability of self-learning. Other two items of conclusions you can see in this slide. Thank you for attention.